All right, now that we talked about what to do if these problems get a little uglier, we're going to get to a slightly uglier problem. We're going to add vector A and B as you see them over here on the left-hand side of the board. But now we don't have A and B going the same direction. We don't have A and B going opposite directions. So A right over here has a magnitude of 6. It's going to the right and it's horizontal. B has a magnitude of 8. And B is going up. B is a vertical vector. So the key rule when we don't have those nice, easy problems, when we're working with vectors, as I just explained, is you make sure that you break all of the vectors up into their horizontal and vertical components. That's the go-to move. This is still what I would consider an easy hard problem. In other words, it's a step above going the same direction or going opposite directions. But if you really look at those vectors, they're already broken up into their horizontal and vertical components. A is completely horizontal, the vertical component is 0. B is completely vertical, the horizontal component is 0. So that really makes our life kind of easy. So here's what we're going to do. We're going to add those vectors up using the head-to-tail method, as we've already gone over. So I'm going to redraw the vectors without changing their direction or magnitude as best as I can. And so I line these up and they are perpendicular to each other. So A is horizontal, B is vertical. Should be a 90-degree angle between them. And then I just need to find this vector right here. And don't make this mistake in your problems. If I just found this number, that would be the magnitude of the resultant. If I'm asked to find the vector sum, or the resultant, you have to find this angle down here too. Because the angle will tell us direction, the exact direction. We know this one is exactly horizontal. We know this one is exactly vertical. This one needs some kind of direction over here. The sum needs to have direction. When you look at this, you might start to realize now why this becomes one of the easier, more in-depth problems. Again, we'll get even more in-depth than this. This isn't quite as easy as going the exact same direction or going in opposite directions. But still, we don't need a ton of math here because you should recognize that if this is horizontal and this is vertical, this makes a right triangle. And so if we have a right triangle, we should just be able to use the Pythagorean theorem to find this magnitude up here. So that's what I'm going to do. I'm going to say that 6 squared plus 8 squared is going to equal my resultant's magnitude squared. I'm going to just write it like that. And so solving this, we get 36 plus 64 is the resultant squared, and so that would be 100. And so don't forget to take your square root then, you would just get 10 is the magnitude of our resultant. So now we know this has a magnitude of 10. But please do not forget that you are not done if you are asked to find the vector sum or the resultant. You still need to find that angle. And so we should be able to do that with a little bit of trigonometry. It looks like B is my opposite side, A is my adjacent side. And so the tangent of theta, which is what I'll call that angle, is equal to opposite over adjacent. And so the tangent of theta is equal to 8 over 6. And now this is where you have to use those inverse trig functions. So theta would be the inverse tangent of 8 over 6. And then you just go to your calculator, which I did ahead of time, and you should get that this angle right here is 53.18 degrees, or thereabouts, assuming your calculator is in degrees mode. If your calculator is in radians mode, you're doomed to get the problem wrong. And so there's the true sum of A and B. The true sum, the resultant of A and B, has a magnitude of 10 and a direction of 53.18 degrees above the horizontal.